Okay, this is example 7. This is Alexander number 320. And what I need to do is find the node voltages. So let's start with step 1, which is to assign. All right, and the node voltages are already assigned for us. What we do want to know is the currents. So in this case, we have I1 to 0, I2 to 0, I2 to 3, and I3 to 0. Okay, so this is actually kind of a tricky problem because what we will notice is that there are two supernodes. All right, there's one located here. All right, and there's also one located here. Okay, and that makes our lives a bit tricky. So what we can say is what's connected in parallel across these two supernodes. If we consider these two supernodes as one big supernode, well, what's connected in parallel is this 2 ohms, which means that we don't care about it anymore. All right, and so that means that we can write our KCL for the two supernodes, all right, as being minus I1 0 minus I2 0 minus I3 0 equals to 0. So that gives me minus V1 minus 0 over 4 minus V2 minus 0 over 1 minus V3 minus 0 over 4 is equal to 0. So that would give me then that I have V1, if I multiply through by 4, by the way, 4. And actually, it's even better to do negative 4 to get rid of that negative sign. I should get V1 plus 4V2 plus V3 equals to 0. And let's call that equation 1. All right, now I just need constraint equations for each of these supernodes. Let's start with the upper one, the 12-volt source. We see constraint 1. We see that V1 and V3 are where it's connected between. And you can see V1's at the plus side, so I take V1, and V3's at the minus side, so I take minus V3 is equal to 12. All right, this will be equation 2. And then I need to write constraint 2. All right, so now I'm looking at the orange encircled one. That's the dependent source. And I know that then V1, which is at the plus side, has to equal, so let's write V1 as the plus, and V2 is at the minus side, minus V2 has to equal to 2I. All right, and furthermore, we know that I is equal to V3 minus 0 over 4, or in other words, I3 0. All right, so that means that constraint 2 is reduced to V1 minus V2 equals to 2V3 over 4. All right, so let's collect all the voltages on one side. I should get then 2V1 minus 2V2 minus V3 is equal to 0. And this would be my equation 3. Okay, so now I just need to put these into matrix form to solve the 3 equations, 3 unknowns. That's going to be, it would be a little bit more complicated to do it by hand. All right, so A matrix, my equation 1 was equal to 1, 4, 1, 1 times V1 plus 4 times V2 plus 1 times V3. And the result there was equal to 0. All right, my equation 2 was the constraint equation for the 12-volt source, and I get here 1 0 minus 1. So V1 minus V3 is equal to 12. And then my equation 3 was 2V1 minus 2V2 minus 1V3, and that equals to 0. So we would take A inverse B using MATLAB or a calculator. All right, and when I do that, I would find that V1, V2, V3 is equal to minus 3 volts minus 4.5 volts and minus 15 volts. And that is my answer. Those are all the node voltages in this problem.